What we do here in Sagence, we reduce the power consumption in the compute node, 10x. We reduce the power consumption with the off-chip memory access by an order of magnitude as well. Together, with these two elements, if you can reduce the power consumption by an order of magnitude, you are in a very sweet spot. You've solved a lot of problems for the industry. Of course, the question, right? The question comes on how do we do that? And really, the final frontier of being able to do that, however many challenges there are, the final frontier to be able to do that is not that you move on your chip, that you move your storage closer and closer to compute, or even interleave it, while keeping all the adders and the multiplexers in place. The final frontier is to collapse the two. So what do we do? How do we achieve it? What we do is, in one transistor, we use multi-level technology. So we have a 24 to 48 to 1 advantage in storage density because we're using multi-level. We don't need 24 to 48 transistors to store a parameter. Just one transistor. We use the same transistor to do compute. We don't need a 500 transistor multiplier to do compute. So we have a 500 to 1 compute density advantage. And there's no data movement between compute and storage. The solution to this problem, at least in the near future, is just collapsing compute and storage absolutely to one unit, trying to reduce that unit in size as much as possible so that you get good economic viability. Right. Now, with that, what it gives us now, if we can solve the power problem, we inherently solve the cost problem too, because we don't need to scale technology to reduce power consumption. We can get very high performance without having to scale technology.